Alright, so welcome to this class. We are going to be looking at the roster and the set builder notation. Okay, so I talked about these two just a little, okay, when I was introducing the set theory. Okay, so we said we had how many times of representing a set? We said we had three. Okay, so the first one we said was uh, where you are describing a set using words. Okay, we said that was verbal. Okay, verbal description. Okay, and then we also said we had roster form, and then we had what? The set builder. Okay, so most of the questions that will be coming will be based on the roster form and the set builder what notation. So you can either convert your set from the roster form to the set builder, or from the set builder notation to the what? To the roster form. So those are the questions that we are going to be what? Dealing with. Okay, so what did we say this roster form and this set builder notation are? Okay, so we are going to go over them. So let's start with the roster form. Okay, so the roster form is what you guys are used to. Okay, the things that we are doing at grade 12, that's the roster form of representing a set. Okay, so this roster form here is just a method where we list, okay, we list the members of the set. Okay, you list the members of the set. So when you list the members of the set, you are using the roster form, okay, of a set. This is the roster form. So for example, I can say my set A is equals to, okay, and then I put the words, or let me just use numbers. So maybe say 1, 2, 3, 4, 5. Okay, so you can see that I've listed all the elements in this set A. So this listing method is what we call as the roster form. And then when you talk about the set builder, okay, when you talk about the set builder notation, okay, it's a way of describing the set, okay, not really using words, okay, but describing it in a set builder notation. Okay, so for you to understand what a set builder notation, you can say it's simply a method, okay, that lists the rules that determine whether an object or an element is part of the set rather than the actual element. Okay, so in this set builder notation, we are going to be describing a rule that will determine the elements that will be in that set. Okay, so for example, we can convert this same set here. Okay, we can convert this same set A here that we had in roster form. We can convert it to what? To set builder notation. So we can describe this set using a rule. Okay, so we can say set A, okay, is a set of all the x's. Okay, and then we say such that x is a member of natural numbers, okay, where this x is less than or equal to 5. Okay, so you can see that from the set builder, we are not specifying the elements that are in that set, but we are describing a rule that will tell us the elements that are in this set. Okay, so someone might be confused because of this, what I've written here. Okay, so x is a member of natural numbers. So from our previous lessons, we said that the set of natural numbers, okay, is a set that contains elements that start from 1, 2, 3, all the way up to what? Positive infinity. This is what we said. Okay, so in short, all the positive whole numbers make the set of the natural numbers. Okay, so we can see that in this set A here, in roster form here, these are just the first 5 elements, okay, of the set of natural numbers. Okay, so how can we describe this set now using a rule? Is what we've done here. We've put that set in set builder what notation. Okay, so depending on what you have here, all these are symbols that you can see in the roster form there. They have a meaning. Okay, so let me explain what they mean in case some of you are confused, so that it will be very easy for us to convert from one form to the other. Okay, so I'm going to write a set here. Let's say we have this set. okay, that is in this form. Maybe I say curly bracket, and then I say x, and then a vertical line there, and then x, and then we say x is a member of maybe natural numbers. Okay, so what do these symbols that I can see here mean? Okay, so each one has a different meaning. So the first bracket here, okay, the first bracket there means the set of. Okay, it means the set of. And then this x here means all x. Okay, or all x's. Okay, and then this vertical line here, okay, means such that. So this is mathematical language, right? Okay, such that. And then the other ones, you know, so this one here is just a set of natural numbers. Okay, and then that e there, we know that it means what? Member of, or belongs to. Okay, so I'll just write member of here. So the way we have it like that, it means it is in set builder notation. So we are going to read this set as set A is a set of all, okay, a set of, let me be using blue. Okay, so set A is a set of all x's such that, okay, this x is a member of what? Natural numbers. So that's how we are going to be interpreting the what? The set builder form. Okay, and remember I said the set builder form just gives us a rule, okay, as to which element will belong to that set. Okay, so for example, this same set that I've written there, it will contain all the elements from 1 all the way up to positive infinity. So if we wrote that set in roster form, okay, it will just be 1, 2, 3, and then you go on until what? Infinity there. So you write 3 dots at the end. Okay, so these 3 dots at the end there, they mean it's an ellipsis. Okay, it's an ellipsis. So ellipsis means there are other elements that are in this set, but we've not written them down. Okay, so that's what these 3 dots mean here. They are not there for decorations, guys. Okay, so anything in math has a meaning. So if you didn't know, that's what they mean. Okay, we call them ellipsis. Okay, so they mean there are other elements in this set, but we've not written them because there are so many numbers in that set. All right, so I've explained what the roster form is. I've also explained what the set builder notation is. Okay, so we can now solve practical questions. Okay, so let's go to practical questions now. So please, if you have any questions, I'm very open to making you understand. Okay, so just unmute yourself and then you can ask your question. Okay, so let's go to the next page here. So we have questions now there. So these are practical exam questions. Okay, so the first one, they are saying represent each of the following set in set builder form. So the first one there, what can we see? Okay, they are saying set A contains 2, 4, 6, 8. So we see that the pattern here will continue to be 10, 12, just like that. Okay, so what do you think this set will look like when we put it in set builder notation? Anyone who has an idea? What do you think the set will look like if we put it in set interval notation? Come on, guys, let's interact. Okay, what will be that set in set builder notation? So we just have to find the rule there that would describe this set. So what rule can we use there to describe the elements that will be in set A? Okay, so set A there is just describing a set of even numbers. Okay, so 2, 4, 6, those are just even numbers. So verbally we can represent this set as a set of even numbers. Okay, but now we want to write it in set builder what? Notation. So we are going to say, okay, this is the first one. We're going to say set A, okay, is a set of all x's, okay, such that just a minute, such that, okay, x is an even number. Okay, so this is one of the ways in which we can represent this set here. Okay, and then we can also represent this set in this form. Okay, so the form in which you represent is not limited to one answer. Okay, you can represent it in a number of ways. Okay, so let's represent it. Okay, so we can also say that this set A is a set of all x's, okay, such that x is equals to 2n, okay, where this n is a member of what? Natural numbers. So remember the natural numbers, okay, remember we said the set of natural numbers. Let me write it on top here. So the set of natural numbers here contains the numbers 1, 2, 3, 4 until positive infinity. Okay, so if we describe set A as this, it will be correct. If we describe it as this, it will also be correct. Okay, so on the second part here, we are saying set A is a set of all x's such that x is equals to 2n, where this n is a member of what? Natural numbers. Okay, so this n here can take the value of what? 1, 2, just like that. So if it takes the value of 1, then our first element in this set will be 2, comma. If it takes the value of 2, our second element here will be 4. If it takes the value of 3, it will be 6. It will take the value of 4, it will be 8, just like that. And that's what we can see in this set there. Okay, so you can describe it in this way or in this way. Both of them are what? Are correct. Okay, so is that clear? We can proceed to the next one.
Sorry, sir, could you please explain on the second one? My network dropped.
Okay, so I was saying the second method there, okay, is exactly, okay, the same as the one that I've written on top there. Okay, but we are just representing it. Um, we are just representing it in a different way. Okay, so for a number to be an even number, okay, then it means there's a 2 involved somewhere there. Okay, so we are going to say this set A is a set of all these x's such that this x is equals to 2n. Where are we putting 2 here so that it becomes an even number? Because in this set we can see all even numbers, right? Okay, and then this n here can take any value as long as it's a what? A natural number. So the natural numbers start from 1, 2, 3, 4, 5, just like that until positive infinity. Okay, so I was saying now this form here is also correct because it describes this x here, okay, as an even number. Okay, so in another way in which you can think of it, if you are representing sets in set builder form, okay, if you are representing sets in set builder form, you can think of it as you are trying to find a formula for the elements that are in this set. Okay, so remember, maybe let me refer them to the sequences. Remember the APGP, okay, those formulas that you are finding in order to describe the APGP. Okay, so it will be a bit similar to that. You're just trying to find a formula that would describe the elements uh, uh, in that set that are in roster form. Okay, now we are putting it in what? Set builder notation. All right, so any questions there? All right, so let's look at the second one there. Okay, so on the second one, anyone who has an idea of how we are going to describe that set? Okay, anyone who has an idea of how we are going to describe that set? Okay, so that set is actually very easy. Okay, I don't know if I've taught you the rational numbers. Okay, Sheba, you have a question?
I just wanted to answer.
Oh, yes, you can answer.
So we can say set B
Mm-hmm.
is a set of x such that x is a member of rational numbers.
Exactly. Okay. So this one here is very simple to represent. So when we talk about rational numbers, guys, these are just numbers that you can present in the form a over b. So in short, numbers that you can represent as a fraction. So when we go to this set here, if we try to find a pattern that they're using from one element to the other, okay, there's no pattern there. Okay, there's no pattern. So you are just going to say b, okay, is a set of all x's such that x is a rational number, okay, such that x is a rational number. But you're not going to end here, because if you say only x is a rational number, okay, it means the whole set of rational numbers. Okay, so you said such that x is a rational number, okay, where this x is a member of, and then you write the same set that you have there. So you're going to say 1 over 3, 1 over 2, 3 over 5, and then 2 over what? 3. So you've represented this set that we have on B here in form of a set builder notation. Okay, so x is a rational number such that x is a member of this set here. All right, so any questions there? Okay, if there are no questions, you can also represent this set in symbol form. So we are going to say this is a set of all x's such that x is a member of, okay, so this rational number here, its symbol is a q, like that. Okay, so we are going to say q, meaning it's a this x is a member of rational numbers, okay, such that this x is specifically a part of these or the following what rational numbers: 3 over 5 and then 2 over 3. Okay, and then you put your other bracket like that. So that's how we can express those sets in set builder notation. All right, so I hope you guys are understanding. If you have any questions, please feel free to ask. Okay, so I want you guys to learn. Otherwise, I'll go to the next question, which is question 1b. Okay, so we are solving question 1a here. So question 1b, now here we have been given the roster form, and then we are trying to find, I mean, we have been given the set builder notation, and then we are trying to find the roster form. Okay, so how do we find the roster form? We just go and see what the x is defined as in this set. Okay, or it can be m, for example, here. Okay, it can be any letter. Okay, here they can use any letter. Okay, so but the most common one is x, so they can use y, p, m, n, any letter. So don't get confused in case you see a different letter. So they're saying write the following sets in roster form. Okay, so we have to list the element in this set here. Okay, all right, so they're saying set P is a set of all x's such that x is a member of z. So z is a set of which numbers? Hello? Yes? Chiba?
It's a set of integers.
Yes, okay. So the set of integers, if you didn't know it, okay, it's the set that contains all the negative numbers. Let me do this. Okay, so you start with the ellipsis, and then you can say minus 3, minus 2, minus 1, 0, 1, 2, 3, and then another ellipsis like that. So you see that here it continues until to minus infinity. Even there it continues until to positive infinity. Okay, so the set of integers is the set of all the negative and positive numbers, okay, but removing all the fractions, and then you are including what? A zero there. So this is the set of all integers. So we're being told here that this set P is a set of uh, all x's such that this x is an integer, okay, and this x is between 2 and what? 5. So if it's between 2 and 5, okay, so it means that the elements in set P, we're going to say number 1. So the elements in set P will just be, we are going to start at 2, so it will be 2, 3, 4, 5. Okay, I think we end on 5 there. Okay, so these are the elements that are going to be in set P. Okay, 2, 3, 4, and 5. Okay, so we're able to list those elements there because we are considering a set of what? Integers. If we had a set of if we had a set of real numbers here, it means we can't list the elements in this set. Okay, but because it's a set of integers, we can list them. Okay, because if you consider the set of real numbers there, it will include the fractions, so meaning the numbers that are between 2 and 5 will be endless. Okay, you have the 2.1 there, 4.9, 4.991, 3.4. Okay, it will be endless. But because we are considering the set of integers, it means we can list this set. Okay, so that set P there will just be this set that contains 2, 3, 4, and 5. All right, so any questions there before we go to the next one? All right, so let's solve the other one then, if there are no questions. Okay, so B, our part 2 there, it's very simple. Okay, so we are saying set Q is a set of all m's such that this m is a letter in the word, this word here. Okay, I don't know how to pronounce that word, but we can see that word, right? Okay, so how are we going to express this set in roster form? Okay, we're just going to say this is the set. Okay, and then we are going to list all the letters in this set, making sure that we do not repeat any letter that appears twice. Okay, so I'm going to say zero. I'm going to say O there is a part of that. I can also see S. I can also see T. I can see E. Okay, I can see A. I can see R. I can see H. And I can see what? I. Okay, so this is the set in roster form. Okay, so this is um, in terms of set builder, and then this one here is set of roster form. So you notice that for all those data that are appearing twice, I'm just writing them once here. So 1, 2, we have 2s there, but here I've just written 1. We have about 3t, 1, 2, 3, but here I've just written 1. Okay, so make sure that any letter that is repeating, you're just writing it what? Once. So the set Q will just be this set here. All right, so any questions there, guys? Any questions? Okay, no questions. All right, so let's proceed. So that's it about the roster and um, the set builder notation. Okay, so now let's use this information of the roster and the set builder to answer the following questions that I'm going to show you. Okay, so the first question is here. Okay, so they're saying with only one of singleton, empty, infinite, classify the following sets and give a reason. Okay, so we have some of the sets there that are in set builder notation, and we have some sets there that are in roster form. So we have to classify those sets if they are one, a singleton set, or they are empty, or they are infinite. Okay, so the first one, they're saying set X is a set of all the x's such that x is between -2 and 0, where this x is a natural number. Okay, so where can we classify this set? Is it a singleton set? Is it empty? Is it infinite? Anyone who can try? When you give us your answer, you even explain why you think so. Okay, so how are you going to classify the first set there? Okay, you can go on.
I think this set is an empty set because if you look at the intervals here, we have -2, which is less than x. You also have less than 0, and x is a member of natural numbers. But when you look at this set, we know that this we have integers here, so it can't qualify to be a member of natural numbers. So that's why we're saying it's an empty set.
Okay, yeah, so excellent. Okay, so we see a contrast here because here we've been told that x is a natural number, and I've told you what natural numbers are. Okay, the numbers 1, 2, and 2 positive infinity. Okay, so we have two contrasting scenarios here. We have x is a natural number, and again x is between -2 and 0. Okay, so there is no natural number that is between -2 and 0. Natural numbers start from 1. So we are going to classify this set as an empty set. Okay, this will be an empty set. And then 2 there, they are saying y is a set of all x's such that x is an even number and x is also prime. Okay, so we know that an even number should be in the form of 2n. Okay, so 2, 4, 6, 8, 10, 12, those are even numbers. And then if a certain number, let's say x, is a prime number, okay, then we know that it should have two factors, itself and 1. Okay, so examples of prime numbers, we have 2, 3, 5, 7, 11, 13, okay, and so on. So these are examples of prime numbers. Okay, and then let's write even numbers on top here. So we have 2, 4, 6, 8, 10, 12, until forever. Okay, so here they are saying x is an even number and x is also a prime number. So we are finding a number, okay, that should be in the set of even numbers and should also be in the set of what? Prime numbers. So that number is only 1. Okay, as we can see from the list that I've given here. Okay, so we only have one number which is prime and it's also even. It's just the 2 there. Okay, so the 2 is prime and it's also even. So it means this set y here is going to contain only 2. Okay, and remember when we're defining a set, we said any set that has one element is called a singleton set. Okay, so it has no partner, it's single. Okay, yeah, so that's a singleton set. Okay, and then let's look at the third one. Okay, so the third one is easy to tell because I explained what those three dots are. Okay, I said if you have three dots in a set, what do they mean? Okay, they just mean that the set goes on, okay, until positive infinity or until negative infinity. Okay, it has no end. Okay, so this one here, just by looking at these 1, 2, 3 dots, okay, we can say that this one here is an infinite set. Okay, we cannot list all the elements in that set. Okay, right, so that's an infinite set. And then the last one there, they're saying the set of, okay, so this is 4. They're saying the set of all straight lines that are parallel to the y-axis on the y on the xy plane there. Okay, so how many lines are parallel to the y-axis? Okay, so let me draw an axis here. So if for example I have this as my axis, this is my y, okay, and then I also have my x like that. Okay, so let's say that this is my y-axis, so I'm going to write y, and then this is here my x. Okay, so they are saying this set here is a set of all lines that are parallel to the y-axis. Okay, so if they're parallel to the y-axis, it means they are going in the same direction as the y-axis, right? So we can draw any line there. Okay, we can draw any line here. Let me get a straight line here. Okay, so we can draw any line on this xy plane. Okay, so if I draw a line here, that would be one line that is parallel to the y. If I draw another one, that would be the second line. If I draw another one, that would be the third one. If I draw another one, that would be the fourth one. Okay, so you can draw as many lines as you want, and all these lines here will be parallel to the what? To the y-axis. Okay, so we see that there's an an infinite number of lines that will be parallel to the what? To the to this y-axis. Okay, so how can we consider that set? We see that that set will just be what? An infinite set. Okay, why? Because we have a lot of lines that are parallel to the what? To the y-axis. So we are going to classify this last set here as an infinite set. Okay, so we've used the set builder notation and the roster form, okay, to identify these sets. All right, so any questions, guys? Any questions that you may have that you need clarity on? All right, so if there are no questions, okay, that's it for today's lesson. Okay, so we've learned the roster and the set builder notation. Okay, so for any questions, always feel free to contact me. Okay, I'll always help you. I want you guys to pass. All right, so I have an assignment for you as always, because I believe you need to practice to understand these things. Okay, so this is the assignment there. You can take a screenshot, but I'm going to send the picture in the group. Okay, so you can try out these questions, okay, on your own. You see if you've understood whatever I was explaining today here. All right, so if there are no questions, then that's it for this class. Thank you so much for attending. Okay, so our free classes continue tomorrow, and our classes will be free this week. Okay, so our classes are free this week, but those who want to register, you can register with us. Our classes are 150 per course per month. Okay, and we do not take more than 50 students. Okay, because our website, which is under development, will not allow us to have more than 50 students, so we only take 50 students. Okay, so if you want to be among the first 50 to register, please feel free to contact me. Okay, so you can secure yourself a slot by registering at least for one course. Okay, so by registering, it means you need to make a payment of 150, and then you keep that slot for you. Otherwise, have a blessed night.